जनवरी 2021 है ये. Okay, unit 1. So question number 1 है, which of these compounds has the same empirical and molecular formulae? So means that I can divide it by 2, so it would be CH2. I cannot divide it. It can be divided. It would be giving you C2H5, or it would be giving you CH2. Basically, I'm going to divide by the smallest number. So in option B, empirical and molecular formula, they are the same, because I cannot divide these two numbers with the smaller number, that is 3, because 8 is even number and 3 is your odd number. This is molecular, this is empirical. Molecular and empirical formulae both are different, but in option B, empirical and molecular both are same. That's why option B is your answer. There are 6.02 exponent 23 atoms in 0.25 mole of, in 0.25 mole of. So you have to calculate the number of atoms. So you must get this number 6.02 exponent 23. So okay, 0.25 multiplied by 1 multiplied by, like, 6.02 times to the 23. Okay, because it has only one atom. It has only one atom. Okay, so of course it's wrong. And if you are going to calculate B, that is H2O. So how many atoms? So 0.25 multiplied by 3 multiplied by 6.02 exponent 23. Again, 0.25 multiplied by 4 atoms into 6.02 exponent 23. 0.25 multiplied by 5 multiplied by 6.02 exponent 23. So what's the answer for 1? What's the answer for B, then C, then D? Yes. In option A, you would be getting this one, if I'm not wrong. If I am not wrong,
Yeah,
for
correct.
option B, you would be getting 4.52 exponent 23. And what's the answer for option C? This one. And for option D, this one.
Yeah,
Option C is correct, because in this option I'm getting this much atoms.
okay.
Which aqueous solution has the highest concentration in mole per dm cube of chloride ions? Highest concentration of chloride ion. So what they have given to you, the mass. So 0.1 over the molecular mass of HCl, that is 36.5. And in this 0.1 divided by the molecular mass of NaCl, that is 58.5. Okay. In C, 0.1 divided by the molecular mass of KCl. I don't know what the mass of KCl. KCl is 39, and then chlorine is 35.5. So what's the molecular mass for KCl?
74.5.
74.5, and then for D, 0.1 over the molecular mass of barium chloride. So what's the mass for barium chloride?
I'm 127.
126. This would be giving you the moles, moles, and mole of HCl, of NaCl, of KCl, of barium chloride, BaCl2. And after getting the moles of that salt, then of course the mole ratio between HCl and Cl is 1 is to 1, of course, because HCl is going to give you only one Cl. Okay, HCl is going to give you only one Cl. Same goes for sodium chloride, same goes for potassium chloride, and barium chloride is going to give you the two chlorine, the two chloride ions. So I would be applying the mole ratio between barium chloride and Cl, that is 1 is to 2. 1 mole of barium chloride is going to give you 2 moles of chlorine ions. Okay? Next, when I would be multiplying this by 2, so I would be getting the moles of chlorine. Then I can find out the concentration, okay? Because they are asking the highest concentration. So first of all, tell me, what's the answer for the first one? 0.1 over 36.5, yes?
0.002.
0.002. For the next one,
0.0017.
okay, third one,
0.0013.
0.0013. The fourth one,
0.0007.
0.007, okay, mole. I have to find out the concentration. Okay, so the concentration would be
There are three
mole
zeros.
30. Okay, 30. Okay, that is this. Huh? Mole upon dm cube. Since the volume is 1 dm cube, so of course that is the concentration as well. Like mole per decimeter cube, mole per decimeter cube. Mole per decimeter cube per decimeter cube per decimeter cube. Since A is the greatest answer, so that's why A is your correct option. Okay. And if you can calculate the concentration for the D, so you would not be getting the greater answer. Like PaCl2 and Cl ratio is 1 is to 2. I have the moles of barium chloride. That is this. I have to find out the moles of chlorine. So the mole ratio is 1 is to 2. So we would be getting 0.0014 mole of Cl. Again, this is the highest answer. That's why option A is correct. Okay. Question number 4. Which conversion has the percentage atom economy per mass for the formation of calcium chloride? So first of all, you need to know what is the formula for atom economy. Atom economy, let's suppose it depends on the product side. Let's suppose this is my product. So calcium chloride divided by the total mass of product multiplied by 100. Of course, would be cancelling. So the atom economy would be 100%. Okay, if you can check option B. So so in option B, obviously, you will see that, let's suppose I have to find out the percentage economy for the calcium chloride. So calcium chloride divided by calcium chloride plus hydrogen multiplied by 100. Then same goes for this, same goes for this. So remember, you have to calculate the masses, okay? You have to calculate the masses, and then you would be getting different answers. Then you have to see which one is having the lowest percentage. Of course, it's not the lowest percent. It's 100%. I'm talking about option A. Option A is wrong. Then you have to check option B. Then you have to check option C. You have to check option D for doctor. So after getting the molecular masses, you would be having a clear idea that what would be the answer. So as I did For option A, it's 100%. We can also calculate for the B. What is the molecular mass for calcium chloride? First of all, tell me this.
110 point. 111, you can say.
111. Calcium is 40 and chlorine is 71. So 40 plus 71, 101. Divided by 100 and 113. So it's 101 divided by all the masses. That is 101 plus H2O is 18, CO2 is 44. Total would be 173. So for the D option, triple one divided by Na2CO3 is 106 plus triple one. The answer is 217. Okay. When the denominator increases, so the overall answer decreases. I would be getting the lowest percentage atom economy. Answer is D. Okay.
Okay.
Hmm?
Yeah.
Question number five. Which of these atoms has the most neutrons? Which atom of these atoms has the most neutrons? You have to subtract it, mass number, and then proton number. Okay. So that would be 115 minus 49, 124 minus 50, 123 minus 51, 124 minus 52. So then you would be getting the answer. Of course, the answer is B. That is going to have most neutrons. Okay, simple. A p block element in period 3 of the periodic table reacts to form an ionic compound. Okay, what could be the electronic configuration of the ion formed by this element? So in period 3, of course, period 3 starts from sodium, magnesium, aluminum. Okay, these are metals. They have to form an ionic compound. Okay, so ion formed by this element, and we have non-metals as well. They are that are going to form ionic compounds. They are talking about the p block element. Where is the p block element? This is the periodic table. S block, then p block, then d block, and this is your f block. So they're talking about this one. In your p block, we have non-metals, and non-metals have to gain electron, and after gaining electron they would be having a negative charge. That's it. So 1s2 2s2, it's ending on s. It's from s block, it's p block, it's d block, it's p block. B and D may be correct. B and D may be correct. How many? Like you can see that, like it's going to have third period. It's going to have third period. It's going to have fourth period. So that's why option D for ball is correct. Okay. The configuration when it's ending on 3, which is going to give you the period number, and this alphabet is going to give you the block, like the p block, and the power is going to give you the group number. It's going to give you the group number. Okay, so of course its group number is a, yeah, 6. Okay, simple. Okay, 7. The period 2 element with the highest melting temperature is period 2. Trend of melting and boiling point decreases across the period, because when we go across the period, when we go from left to right, we are going from metal to non-metal. Generally the melting and boiling points of metals are higher as compared to the non-metals. So we have aluminium, then boron, then carbon, then silicon. So this is understood that the highest melting or boiling temperature would be of of carbon, because this is in group 2. This is in group 2, oh sorry, period 2. Like period 2 starts from lithium, beryllium, boron, carbon. Silicon is not in period 2. uh it's in other period, but it's also having the highest boiling and melting temperature. Okay, it's also has. Okay.
Okay.
Carbon is in the form of diamond and graphite. That's why it's going to have highest melting and boiling temperature. Okay. Which of these has the greatest electrical conductivity? Which of these has greatest electrical conductivity? So electrical conductivity, it's ionic compound. It's bad conductor in solid state because ions are not free to move. It's mercury. It's a metal. Of course, metals are good conductor of electricity. It's understood. So that's why option C is correct. B is water, liquid. Water is a bad conductor. And SF6 is a gas. Gases are also bad conductors. Which of these ions has the greatest ionic radius? Normally, generally, an ionic radius are greater than the cationic radius. Like the size of an ion is greater than the cation. So we have sodium, aluminium. They are wrong because they are cations. Then we have to see option A and B. So remember, when the charge increases, like of course nitrogen is going to have 3 minus charge. So I told you across the period size decreases. If you can see the periodic table, so you will see that sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, then argon. Okay, and if you can see the second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So this is the nitrogen and this is the fluorine. So I told you that the size is going to decrease. So of course, fluorine would be having the lower size. So nitrogen is going to have the greatest ionic radius. So that's why option A is correct. Greatest ionic radius. Option C and D are completely wrong because they are cations. Cations are generally smaller cation as compared to anion. Then we have to compare A and B, that is nitrogen and fluorine. So of course, nitrogen is going to have the higher ionic radius. Okay. Question 10. Which of these ions has the greatest polarizing power? So, polarizing power means that it depends upon the multiple factors. Like, let's suppose, uh, uh, you know, anions are not going to polarize cations. Anions, anions are not going to polarize cations. So, so means that option A and option B, they are wrong. Option A and option B, they are wrong. Remember, like they are asking greatest polarizing power. Greatest polarizing power. So ions are not going to polarize the cations. Okay. So they are not going to have polarizing power. So then we have to decide in C and D. Then we have to decide in C and D. So C is K plus and D is Ca2 plus. Since the charge on calcium is higher, that is plus 2. Since the charge on calcium is higher, that is plus 2. So of course it would be having the greater polarizing power. This is the reason option D is correct. This is the reason option D is correct. So so we have two important factors: greater charge and lower size, more polarizing power. Okay. Which of these does not have a structure formed by a giant lattice of carbon atoms? You know, carbon giant lattice means that it is supposed to be diamond, it is supposed to be graphite, but they are saying does not have a structure formed by giant. Formed by giant. So it would be a it's not a giant structure. It's a simple molecular structure. Yeah, diamond is giant, graphene is giant, graphite is giant. So fullerene is not a giant structure. Okay. Which of these molecules is the most polar? Which of these molecule is remember y- the one which is going to have the higher electronegativity difference is going to have the most polar one. Okay, so obviously A is correct, because because the electronegativity of fluorine is higher. Electronegativity of fluorine is higher. That's why A is correct. Okay. Then in option like 13, a substance is labeled with the hazard symbol shown. What is the meaning of this symbol? It means that this is corrosive. Corrosive, you can see the hand. Something is pouring on the hand. And this is dangerous because acids are corrosive in nature. Also the strong bases are corrosive. So I would say that this is B, okay, corrosive. What is the IUPAC name of this alkane? IUPAC name of this alkane. So first of all you have to see the longest carbon chain, and then you have to see the branches, how many branches you have, and then you have to locate the position of the branches. Then you will see the correct option. So first of all, I would be selecting the longest carbon chain. What do you think about that? What should be the answer? First of all, yes,
D.
D for doctor. Okay. So this is the longest chain. This is the longest chain. Okay. And
Yeah.
these are the two branches. These are the two branches. So one, two, three. Like I'm supposed to name it. One, two, three. This is also the branch. Four, five, six, seven, eight. So the branches are at three, four, and six position. If you're going to count from left hand side, it would be one, two, three, four, five, six, seven. So eight. So the name of the number of the branches would be 3, comma 5, comma 6. So this is the least number, 3 and 4. As compared to 3 and 5, 3 and 4 is good one. So 3, comma 4, comma 6. Trimethyl octane. Octane. That's why option D for doctor is correct. You are saying D, right? You are saying D, it's C. It's not D.
Yeah.
See this one. Petrol, bioethanol, and hydrogen are fuel. Okay. All three of these fuels, all three of these fuels, so they are going to burn, they are going to produce greenhouse gas, whether you have petrol, whether you have bioethanol, whether you have hydrogen. Greenhouse gas is also a water molecule. Water molecule is also a greenhouse gas. If you're going to burn petrol, it's going to release water. If you're going to burn bioethanol, it's going to release water. If you're going to burn hydrogen, it's also going to release water. So A option is correct. Okay. Why option B is incorrect? Are overall carbon neutral? Are overall carbon neutral? They are not all carbon neutral. Remember. Okay. Like in ethanol, I cannot say they are all carbon neutral. Okay. Are overall sustainable? Okay. All are not sustainable. Remember, hydrogen is highly explosive or highly, you can say, um, like of course unstable. I can say it's having the lightest mass. Okay. So then biodegrade rapidly, so they have different criteria. I cannot say that all are going to biodegrade rapidly. It's not mandatory. Okay. It's not true for all of these, remember. So So option A is correct. Then you can try question number 16. In this question, they are saying cyclopentane undergoes free radical substitution with bromine. Which of these is an overall equation for this reaction? Free radical cyclopentane. Cyclopentane means that the formula for cyclopentane would be C5H10. Remember, the formula for the cyclopentane would be C5H10. The formula for the cyclopentane is C5H10. Okay. So um, that would be option B, C, and D. Option A is completely wrong. Remember, option A is completely wrong because the formula is not correct. Then um, then in free radical substitution reaction, we have learned that it's a substitution. So the B says it's an addition reaction, because only one product is formed. So of course, if any one of the product is formed, which shows that this is an addition reaction, it's wrong. It's wrong. Okay. Then option C, uh, this is hydrogen. This is this is hydrogen. C is incorrect. C is incorrect. So in free radical substitution reaction, we have never learned that the hydrogen was forming. Okay. Only HBr were formed. Only HBr were formed. So that's why this is the free radical substitution reaction. That's it. Okay. Which statement is not correct about this reaction system? Like about free radical substitution. Only the initiation step involves homolytic bond fission. Yeah, this is only the initiation step involves homolytic bond fission. Bond fission means bonds are going to break down. So only in the initiation step this is going to take place, like the homolytic fission. No, it also occurs in propagation step. It also occurs in propagation step. So this statement is not correct. Obviously, option A is correct. Then we have to check B. Only some bromine is converted to free radicals in the initiation step. Yeah. Okay. Good. Propagation forms more product than termination. Yep. Because termination has only one equation. Like we can combine any two of the radicals, so they would be forming a neutral molecule. So this is called termination. And then further substitution reactions are likely to occur. Yeah, this statement is also correct. If you are going to substitute one hydrogen, then two hydrogen, then three hydrogen, then four hydrogens. Okay. So option A is correct. That is like it's not the correct statement. Which free radical is least likely to form in a propagation step in this reaction system? Remember, least likely means that it would not be stable. Remember, it would not be stable. So that is one and only D. D is H. Already it has a very small size. Already it has a very small size, and after getting radicalized, so of course it would be highly unstable. So it's the product that would be least likely to form. Okay, the product should be stable comparatively. The product should be stable. Okay, which alkane could be formed? Which alkane could be formed? So in a termination step in this reaction system, which alkane could be formed? What was the reactant? Of course, we had cyclopropanes. We had cyclopropane. Okay, so when we are going to terminate this reaction, we have to combine the two radicals. We have to combine the two radicals. So this is cyclopentane. This is cyclopentane. So the joining is from the two sides. How is that possible? In termination, I'm talking about. Okay. This is incorrect. This is incorrect. Okay. This is correct. This is correct. Okay. Because, if you can count the number of carbon atoms, you will get to know that 1, 2, 3, 4, 5, 6, 7, 8. So in termination step, the two molecules are going to combine with each other and they are going to form a product. So your reactant was cyclopentane. And let's suppose the radical of cyclopentane is formed, and then again I'm going to react this cyclopentane with the other reactant that is also the cyclopentane. Okay. So the carbon atoms should be the carbon atom should be 10 in the product side. If you can count like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's correct. Okay, so this is option C. Option C is correct. And why option B is also incorrect? Because if you can count the number of carbon atoms in B, if you can count the number of carbon atoms in B, so it also doesn't have 10 carbon atoms. It's something else. If you can count 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9. It's not 10. It's 9. Simple. Okay. And D is completely wrong, of course. Which of these is not a way of limiting global problems caused by polymer disposal? They are biodegradable. They are biodegradable. So some polymers are biodegradable. Some polymers are not biodegradable. Like condensation polymers are biodegradable, but addition polymers are not biodegradable. Okay, but what they are saying in this question, which of these is not a way of limiting global problems caused by a polymer disposal? Because when we dispose the polymer, so we have some like the sun rays are going to strike on this polymer, so of course they are going to release toxic gases. So they are saying in option A, developing biodegradable polymers. It's not a way of limiting global problems, because if you are developing biodegradable polymers, so what about the non-biodegradable polymers? Where would they go? So it's not a solution. It's not a way of limiting global problems. Then option B says exporting polymer waste. Exporting polymer, exporting polymer waste. So where would you export? Where would you export? So of course, over there it would also be the main cause of the problem. It would be releasing some sort of toxic gases, of course. So it's not a way of limiting global problems. Okay, so option B is correct. Option B is correct. And why not C is correct? Why not C? In C they're saying removing toxic gases produced by the incineration of polymers. Yeah, this is good. Yeah, this is good. Like the gases that they are going to release, removing toxic waste gases produced by the incineration of polymers. So we can remove the toxic gases. We have multiple methods. Okay. We would not be having any global problems if you're going to remove some toxic gases. And then why option D is incorrect? Because reusing products made from polymers. If you are going to reuse the product which is made from the polymer, that can also the cause for limiting the global problems. Because of course you would not throw away the polymer because you would be using it again. You would reuse it. Okay. So there is only one option, that is B. This is saying that exporting polymer waste. Exporting polymer waste is not a permanent solution to limit the global problems. Remember. Okay.